Good morning, everyone. I'm NICOLE, RAñOCO, and today I will be discussing measures of dispersion for ungrouped data. First, let us discuss the terms and definitions used in measures of dispersion before applying them in a sample problem. First is the measure of dispersion. The measure of dispersion is a measure of the variability of a set of data that describes the spread of the data in a set. The measure of dispersion includes the range, variation or variance, and standard deviation. The second is the range. The range is the difference or measure of the distance between the largest and smallest values or observations in the dataset. The range uses the formula range is equals to maximum x minus minimum x, meaning the maximum or highest value minus the minimum or lowest value in the dataset. The next is variation or variance. The variance is the statistical measurement of the spread of numbers within the dataset. Additionally, it is the square of the data standard deviation. There are two formulas that can be used to compute the variance. In computing the variance of the population, one uses sigma squared is equal to the summation of the quantity of x minus mu squared over n. In computing the variance of the sample, one uses s squared is equals to the summation of the quantity of x minus mu squared over n minus 1. Lastly, the standard deviation. The standard deviation is the measure of the spread of data around or in relation to the mean. It is the square root of the sum of the variance. There are also two formulas that can be used to compute the standard deviation. In computing the standard deviation of the population, one uses sigma is equals to the square root of the summation of the quantity of x minus mu squared n. Computing the standard deviation of the sample, one uses s is equals to the square root of the summation of the quantity of x minus mu squared over n minus 1. Let us now proceed on how to compute the variance and standard deviation. Firstly, determine the mean of the given dataset by finding the sum of all values and dividing it by the number of values in a dataset. Second, calculate the deviation or difference between each number and the dataset's mean. Third, after finding the deviation or difference, identify the square of each deviation. Fourth, find the sum of the total square deviations. Fifth, divide the summation by n or n minus 1, n as the number of values in a dataset, depending on if you are looking for the variance of the population or sample. 6. Determine the square root of the variance to get the standard deviation. Now that we are all familiar with the terms used in measures of dispersion and their definitions, let's now focus on applying them in the following sample problems. First, let's solve the range, variance, and standard deviation of this sample problem. The dataset includes 5.2, 11.7, 19.1, 3.7, 8.2, and 16. To compute the range, we will need to find the highest and lowest value of the dataset. In order to do this, first we must arrange the values in ascending order. Now that we have arranged them, we can see that the highest value is 19.1 and the lowest value is 3.7. To get the range, we would subtract 19.1 to 3.7, which would result to 15.4. Therefore, the range for this dataset is 54. How to find the variance? First, determine the mean of the given dataset by finding the sum of all values and dividing it by the quantity of values in the dataset. Therefore, if you add them all together, you will get 64 points. Since there are 6 values in the dataset, we can count 1, 4, 5, 6. We will divide 64 by 6, which would result 10.7. So the mean would be 10.7. Since we are looking for the variance of the sample, we will use this formula, which is s squared is equal to the summation of the quantity of x minus mu squared over n minus 1. Now that we have the mean, we can calculate the difference between the given values and the mean. Therefore, it is still the same values. I just arranged them in ascending order. As you can see here, I subtracted each value to the mean. After finding the deviation or difference, identify the square of each deviation. So I squared the answer. And after that, we would find the sum of the total square deviations. So if we add them all together, we would get 188.40. Since we are finding the variance for a given sample, we will divide their summation by n-1, or the quantity of values in a dataset decreased by 1. Since there are 6 values in this set, it would be 188.42 per 6 minus 1, or divided by 5, therefore 37.684. So the variance of this sample is 37.68. Now that we have the variance, we can get the standard deviation. Since we are computing the standard deviation of the sample, we will use S is equal to the square root of the summation of the quantity of X minus mu squared over n-1. As mentioned, to get the standard deviation, we should determine the square root of the variance. Therefore, the square root of 37.684 is 6.13872951. Therefore, the standard deviation is 6.13872951. Let us now proceed to the next sample problem. Again, we will find the range, so we will arrange them in ascending order. So 100 minus 48 is equals to. Therefore, the range for this data set is 50. We will get the variance. Again, we will get the mean. Find the sum of all of it. Then, divide it by the number of values in the data set. So 1, 4, 5, 6, 7, 8, 9. So 790 divided by 9 is equals to 79.88888889, which is our mean. So again, we will need to find the variance. We can calculate the difference between the given values and the mean. As you can see here, I subtracted the values to the mean. And after that, we'll find, or we will identify the square of each deviation. So as you can see here, I squared each deviation, and after that, we would need to find the sum of the total square deviations, which is 2492.888889. So after that, we would need to divide their summation by n-1, or 9 minus 1, or 8, which would result to 311.611111, which would be our variance. Now that we have the variance, we can get the standard deviation. Again, to get the standard deviation, we need the square root of our variance. So the square root of 311.611111 is equals to 17.6551005, which is our standard deviation. Let's now proceed to our last sample problem. Again, we will need to find the range. So arrange them in ascending order. So 96 minus 49 is equals to 47, which would be the range. How to find the variance? Again, we would need to find the mean. We need to find the sum of all values, which would be 809. Then divide it the quantity of values. So 1, 4, 5, 6, 7, 8, 9, 10, 11. So 809 divided by 11 is 70.54545455, which would be our mean. Now that we have our mean, we can calculate the difference between the given values and the mean. So again, I subtracted each value to the mean. And after that, I would get or identify the square of each deviation. After that, I will find the sum of the total square deviations, which is 2844.72773. Since, again, we are finding the variance for a given sample, we'll divide the summation by n-1, or 11 minus 1, or 10, which would lead to 284.4727273, which would be our variance. Again, now that we have our variance, we can get the standard deviation. So the square root of 284.4727273 is 16.8663192, which would be our standard deviation. That is all. Thank you for listening. You can contact me via email or via Facebook. Thank you.